Bullitt Scholarship and the Bullitt Prize for Best Undergraduate Paper. So our undergraduates actually write scientific papers, put them in and get them accepted. So yes, we have a prize for that as well. So I'd like to invite Mr. Laurie Watkins to come up and hand our scholarship and prize out before we get to the lecture. I will warn everybody, these seats have a tendency to eat your wallet. So I have found more than one wallet after my class. I do return them, but you might want to just keep them. So check your seat afterwards. No, Drew has dibs. So, all right, here's the. So the first one is the scholarship, and this is a shared scholarship between Brady Smith. Can Brady Smith come up? Yep, and Trevor Buttram. So seven opposite seven. These are two outstanding seniors, and we were very happy to. You've got to make sure you've got the hold up that. And our second prize is for the best undergraduate research paper, which is for Trevor Buttram, who has submitted his paper on dust in the galaxy. I'm very happy with it. I'm the supervisor, so I'm very thrilled. Sure.
This is titled Astronomer's Library. My grandfather, for decades, collected first edition astronomy books for his personal library, which is now at the University of Louisville, thanks to his widow. And so he had quite a library of first edition books, and it's the speaker tomorrow is going to get to view them at Ekstrom Library. They're in the rare book collection there at Ekstrom.
Thank you to Laurie, who makes this Bullitt Lecture possible. And now, without much further ado, I am absolutely thrilled to introduce Karen Masters. She's presently at Haverford College. Before that, she was at the University of Portsmouth for quite a long time, and Harvard, Cornell, and Oxford. So, you know, all the nice ones, really. And so, but I've known her for a long time because we both work on galaxies. And so as soon as I saw this book come out, I was like, ooh, I gotta have this because I love old books and I love her work. So I'm absolutely thrilled to present to you Professor Karen Masters for the Bullitt Lecture 2024.
Thank you very much for the invitation to give this Bullitt Lecture. Is the microphone working okay?
Yep.
Everyone can hear me? Great. I'm really delighted to be here to tell you about this project, which was a real pleasure to work on. As Benny mentioned, my research area is in galaxies. I study populations of galaxies using big surveys. I'm a pretty traditional research astronomer, although I work at a small liberal arts college where I work primarily with undergraduates on research, and that's really a passion of mine as well. But I love old books. I love learning about books, and I find it fascinating what you can find in books. And so when this project kind of landed on my in my email inbox, I guess, I was like, oh yes, I definitely want to do that. That sounds great. And it's been a real fun experience to learn about books and learn about the history of astronomy books. So I want to give some credits to my collaborators on the project. This was a project with Quarto, which is a British publishing company. It was very collaborative work, particularly with my editor, Roland Hall. We met over Zoom quite a lot. He's British-based. And we talked about different books that we were going to include, which ones had really cool images. And I think if you get a chance to look at the book, it's just really beautiful. It's really beautifully laid out, and that's really all Roland's work. And also big kudos to the other designers who designed a beautiful cover and all that kind of stuff. To my delight, it's now also available in German, which I don't read, but if you want to read it in German, you can do that, and maybe some more languages are coming. This is part of a series that Quarto do of these beautiful kind of coffee table books that are looking at the history of books in specific subjects. So the Philosopher's Library and the Scientifica Historia were out when I was working on the book, and so I have copies of those and kind of found those really interesting. Mine is, I guess, the 5th one in the series, and the botany one is still to come, but that one looks like it's going to be really pretty and really interesting as well. Okay, so Quarto came to me with this idea, the Astronomer's Library, fitting into this series, but then they kind of left it to me. They said, maybe we're going to do it chronologically, just start totally historically. But I wanted to kind of think about organizing the Astronomer's Library more topically, and also think about including books that aren't just from sort of the Western cultures, but thinking about how astronomy books might have intersected around the world. So I came up with this kind of 6-chapter structure for the book. The first 5 chapters are all books that are published at least 100 years ago, and then I left all of the more recent books for the last chapter. So, and then amongst all the books, divided it up into star atlases, maps of the universe. So this is really more about images, books about planets and about mapping the universe. Astronomy and culture. This was an opportunity to kind of bring in books from different cultures and look around the world. I can speak a little bit of French and a little bit of Chinese, as it happens for family reasons, but I'm really not fluent in either. So all of this is me reading about these books because I'm not able to read them myself, but you can read a lot of interesting stuff that people have learned about books. Ben mentioned my research is galaxies. I'm very interested in the universe in general and cosmology, and there's a really nice story there in the development of cosmology that's really told through books, I believe, some of which, some of the really significant ones are in the Bullitt collection, and I look forward to seeing those tomorrow. We also have some of them at Haverford, which is fun. And then a section on textbooks and books, sort of popular science books, which are some of the really beautiful books that have been written to educate people about astronomy, because lots of people love astronomy and it has great pictures, right? So we can do some really fantastic books. But I did look this up, and I was talking about this earlier, so let me, there was a research project that was done a long time ago, it turned out, in 1916. And I learned about this reading the book. I have it written down here. Just over 0.1% of all books in the public libraries in California in the 1900s were astronomy books. So I thought that was an interesting statistic to think about how rare astronomy books are in general when you think about a collection of books. But a number of really cool astronomy libraries have existed through history. So here's a couple of examples of that. This is the Observatoire de Paris, and you can't really make it out too well, but this is the bibliothèque. So this is the library that they built in their observatory. Tycho Brahe kind of had this whole castle to astronomy in Denmark. It got destroyed because he fell out of favor with the Danish kings, so they knocked down his observatory. But the idea is that certainly the plans for this show a library, and certainly that was high tech at the time to have books in your observatory. So it was fun to read about these. I also learned a little bit about the Royal Astronomical Society Library in London. I had the pleasure to go there in person. In the process of working on this book, I had a nice Zoom call with their librarians and talked about the books they have. It's one of the largest collections of astronomy books in the world at this point. This one at Harvard was a very large collection, and the book still exists, just to be clear, but they have closed the astronomy library at Harvard and merged all the books with the other collection just for financial reasons. Just very recently, so actually after the book came out, after my book came out, which is interesting. And the other thing that really attracted me to this project is we have a really cute little astronomy library at Haverford. So this is my astronomy library, mine, I'm taking ownership of it. in the observatory we have at Haverford, and you can see me here teaching a class, for classes that are like, I don't know, up to 8 people we can teach in there. That's becoming more rare these days because the science subjects have become very popular at Haverford. But we also do things like, this was an art class that put some artwork up around the top of the library, so it's a really fun space on campus. Okay, so enough about like the meta stuff about libraries and about writing the book. Let's actually explore some of the books in the library. The title of the talk was Browsing in the Astronomer's Library. So we're just going to kind of go section by section, and we'll start with star atlases. And within each section, I try to be kind of chronological. And so we got some, we're going to start with the star atlases, and interestingly, we have to kind of start pre-book. So the first star atlases that you find, so maps of where, you know, the constellations or maps of the night skies, are not in books at all. We have some really ancient ones from China that were printed on silk. So some of the early Chinese records really persisted well because of the printing on silk. This statue of Atlas from 2nd century Greece is actually the first record we have of the Greek constellations, so the traditional ones you've probably heard of. If there are any astrology fans, right? All of those zodiac constellations or constellations that come from the Greek tradition, also Orion, Cassiopeia, the Big Dipper is a part of a constellation, the Great Bear, Ursa Major, all of those things are from the Greek tradition. And then there's things like this Bronze Age disc. This is from Germany, where it's not totally as clear that this is a map of the sky, but it's certainly a pictorial representation of stars. And another group that, you know, they're really, was told not to look that way. I'm going to go over here. So another group of these astrolabes that really have kind of persisted through history because they're made of metal. So this is from the sort of medieval Islamic era. A lot of those lasted, so you find a lot of those. And so those are a lot of some of the early star charts you find. But if you want to go to books, we go a bit later. And the first book, which has sort of star charts and constellations, and the first book that included those Greek constellations that we're all so familiar with, was actually published in Persia, which is part of Iran today in the 10th century. None of the original copies exist, so no first editions for this one, but there was this Islamic tradition of copying books, and so there's just more and more copies of this book were made, and so you can find a bunch of different copies, they're all slightly different. But I, as a galaxy person, something that I thought was really neat about this was this little blob here at the nose of the fish. So I should say, this is Cassiopeia, the constellation Cassiopeia. It's kind of like a W on the sky. It's not at all, it's Andromeda. I'm making that up. This is Andromeda, excuse me, it's been a long day. And then there's not normally a fish over Andromeda, but the fish was the ancient Persian constellations. So what Al-Sufi did was combine Greek constellations with the Persian constellations, and it was a book kind of comparing them. But just because of the copying, it ended up being the first record we have the Greek constellations, which is kind of cool. Okay, so she's Andromeda, and those of you who know about galaxies know there's a famous galaxy called the Andromeda Galaxy. It's our nearest neighboring galaxy. It's one of the only galaxies you can see with the naked eye without a telescope if you go to a dark site. I have seen it with just my eye. It's pretty cool if you think about it, like how far those photons have traveled to come to your eye. And the cool thing about this map is it shows a little kind of representation of the Andromeda Galaxy, this little collection of stars, this fuzzy blob at the nose of the fish. And I thought that was really cool. I had no idea we had a record of the Andromeda Galaxy from the 10th century. So that was really neat, the galaxy person. Okay, so now we're going to fast forward a bit more. And if I make this a little bit bigger, I can stop looking up over my shoulder. Yeah, that's better. The very first printed star atlas is from 1540, and this is a cool one as well, Piccolomini. I really enjoyed learning about this book because he published it in Italian, not in Latin, which would have been unusual at the time, because he wanted to make an accessible star atlas that people could use. And it's the first kind of time that the constellations are put like kind of separately, and so it's very much like a kind of like a guide to finding the constellations in the night sky. He also dedicated it to an Italian poet who was a woman, with words about how he thought it was a good idea if women got more interested in science and astronomy. So I thought that was quite nice. So this is kind of really just like a little tour through some of the cool books. So I couldn't leave out the Harmonia Macrocosmica, especially with Professor Holwerder here. This is an example of the Dutch golden age of Dutch cartography. So Dutch bookmakers had a phase where they made some of the most beautiful books in the world for quite a while, actually. And some of the most beautiful books in the world they made included these very large-scale atlases of the night sky. And if you look closely at this one, you might think to yourself, wait a second, I can't see any Greek constellations in this. I can't see Orion or any of that. I thought this was an interesting example where I had no idea, I had not heard of this history. They're actually making an attempt to put the Christian saints into constellations. So constellations, right, they're kind of arbitrary. They're dot-to-dot pictures in the sky. The tradition that we mostly use these days is Greek, and that's the one the International Astronomical Union kind of adopted. And so naming conventions are after these Greek constellations. The sky is divided up that way. But it's totally arbitrary. It has nothing to do with the astrophysics of stars. So here in, what's the date, 1660, you see an example of someone suggesting we can have a different set of constellations based on Christian saints. And there's other examples through culture that we'll see as we do our little tour through the library. But one of the other fun things about these is you can see all these cherubs doing things, interesting things. So here are some doing some astronomy with telescopes. And I had a great deal of fun browsing through this book. I will say, unfortunately, I don't have a physical copy of this. It would be really beautiful. But most of these books, because they're at least 100 years old, are they're public domain. So the Library of Congress has a lot of scans of them, and many other internet repositories have scans of these, so you can find a lot of the images and look through them all online. So it was really fun to look through these. And I got really into the cherubs and what the cherubs were up to in the borders of these. So here is just the edge of another one of these maps from the Harmonia Macrocosmica, apologies, I can't pronounce that. And I really enjoyed how, well, these are not cherubs, but here we have on the rooftop people, they're using this thing called a cross staff. So this is the pre-telescopic era. We haven't invented the telescope yet. We still want to measure angles on the sky, and so they had this thing called a cross staff, which they could use to estimate the distances, angular distances between things in the sky. But if you notice way up at the top here, the cherubs also have a cross staff. And in a few of them, you see the cherubs making use of astronomical instruments and doing other stuff. It's pretty fun. So we're going to go forward just a little bit. 1690, and those of you who are in Astro 101, maybe you've learned that the telescope was invented in around 1610. So this is around the era the telescope is actually something that people have access to. But this astronomer named Hevelius, who was from Poland, was not a fan of telescopic observations of the night sky. And in his big map of the night skies, he put cherubs basically casting aspersions on maps that might be made with telescopes. So this is the, gosh, that's a lot of words, isn't it? Firmamentium Silvescium Sive Uranographia, which is the name of the book in Latin. It's a big book of atlases. It was the last non-telescopic atlas. And here the cherub has a little sign saying, in Latin, the eye is better. So this cherub's trying to give them a telescope, and they're saying, no, thank you. They're not using a cross staff, they're using a sextant. So this is kind of the same kind of thing to estimate angles in the sky. You kind of sight along it in different ways. So that was fun. Despite Hevelius's opinions, the telescope kind of did win out, and big telescopic atlases come next. And so the atlas, Soelissus is a big example of that. This was an epic piece of work from John Flamsteed, who was the first astronomer royal. So this was a period in history where suddenly it was realized that these star charts were really economically valuable because they could be used to improve navigation. So you might have heard of the longitude problem, but we can use stars to estimate our latitude very straightforwardly. You can teach anyone to do that really quickly. If you can find the pole star, the angle that it makes above the horizon tells you your latitude. It's really quick. Longitude is much harder, and that depends on knowing something about when you're making observations of the stars. And so a lot of the big royal families for the most part in Europe at this time realized that astronomy could help with this problem, because astronomy can help you find the time. Because the stars move like clockwork, right? They're kind of moving around us in very regular ways. So if you had really good star atlases, we could be better at navigation, and we could win in the kind of economic battles of the era. And so you get lots of observatories being built. This is the Greenwich Observatory in the UK that's built just above the Thames, and you can see all the ships. This is a not totally contemporary painting, excuse me. It's late 17th century, so it's not a little bit later. But what they would do is they would take observations from the observatory to signal what the time was, and send the time signals to the ships in the river, because they could see the observatory. So they had these big balls, just like the New York Times New Year ball, and it dropped to indicate what the time was, and the people on the ships could know the time, and then they would set off around the world and could navigate. John Flamsteed took over a decade doing this, but it was the first telescopic atlas, and it was also the first atlas in the northern hemisphere that recorded the stars that we can only see if you go to the southern hemisphere. And he actually sent off, I think it was Edmund Halley, I might be making this up. He sent off an astronomer, the name of whom is familiar to me, to the southern hemisphere to do this. So there's a little Haverford connection here, and probably connections to most older observatories. At Haverford, we have an observatory that was built in the 1850s, and this is a picture of it in 1857. It doesn't actually look that different today, which is kind of cool. This is my office, this little bit. I should show you. This is what it looks like today. So here's me with some students, and this bit is this bit, but we're kind of on the other side of it. And then they've added this like big classroom and this octagonal bit, which is where they put the library. So this was and they built a bit on the back of it. Anyway, point of the picture is to show you this side, which is not, this is also now an office, but in 1857 it held a transit telescope. It held this telescope, which was used to measure very precisely when stars went across the meridian. So the meridian is the line that goes, I have a picture of it. Yeah. So the meridian is the line that goes from the southern hemisphere to the northern hemisphere, right through the zenith. And every star in the night in the sky will cross it once a day. Some of them do it twice a day. And so you can use the time that those stars cross the meridian to very precisely estimate your time. And so this is before the internet, right? And this is before even the telegraph. And so finding the time in different locations required having an observatory near to that location. I really enjoyed these diagrams, which were from an astronomy textbook. So this is the Earth rotating once in 24 hours, showing how the stars will appear to go around it. But of course, we're standing off on one side, so then we have to tilt the whole thing, and we get these tilted paths of the stars that go once a day. Most of them go once a day through this meridian, and then these ones go twice a day through it because they're called circumpolar, they never set. Okay, so the atlases were fun. And I sort of ended the section on star atlases by thinking about how we're using these today. Like, how do we have star atlases today? So I included this really neat map of Orion, which is one of my favorite constellations. It's about to appear in the night sky any day. It probably already is late at night. And you can see how we've gone from the very kind of elaborate pictures to these kind of stick figures, dot to dots, in our depiction of constellations, very scientific looking. Most modern astronomers don't know that many constellations, honestly. I definitely can recognize this one. But it's not like a big part of being a professional astronomer anymore. Our telescopes tend to be computer run, and so we're able to, we don't really need to know the constellations for the most part, although it's kind of fun sometimes to know them. But I also was really interested in including some more kind of thinking about other ways in which people think about constellations. I already mentioned constellations are kind of arbitrary, and so I was interested in learning about constellations from indigenous people in the United States. Thought that was really interesting. Really wanted to include some of this artwork by Annette Lee, looking at Ojibwe constellations, and in particular, here we have the Wintermaker, which looks really, really similar to Orion, the Greek constellations, which I thought was neat. And And it's an interesting, I think there's been a real reinvigoration in interest in kind of indigenous ways of knowing the skies, so I thought that was cool. Quite rightly, Annette, this is her modern artwork, and she wanted to be paid to include it in the book, so unfortunately wasn't within budget, so we couldn't quite do that, but we were able to put this cave art in the book showing the Winter Maker and other depictions of other Ojibwe constellations that was public domain. And I think it's really interesting, and I hope to continue to learn more about this. I think Benny mentioned that he's used this, but there's this really neat website where you can go and you can look at any star, well, bright stars in the sky, and see how cultures around the world have put it into constellations. And so there's an example with Betelgeuse, which is one of the stars in Orion, as in the Greek tradition. And you can see all the other different stick figures that have been made, including Betelgeuse, including our Winter Maker, the Ojibwe one, and then all other kinds of ones. A lot of people, which is kind of neat. Not always people, but this one's kind of cool. Anyway, it's sort of fun. And you can do this for other different stars. So that's really interesting. All right. So we're going to move on to books now about mapping other worlds. And these were some really neat books as well. So here are some of my favorite examples we're going to talk through. I'm going to kind of just talk through other worlds one by one a little bit. So we're going to start with the sun. It's kind of the most obvious astronomical object out there. What was interesting was to learn, one of the things I learned was that there's actually pretty old drawings of the sun and sunspots on the sun. So this is an ancient record of sunspots by an English monk from 1128, which is pretty cool. It's pretty challenging to observe the sun, right? You shouldn't look at the sun. It will not just during an eclipse, at any time if you look at the sun, you might damage your eyes. I really like the telescope you have out in the courtyard here, where you can point it at the sun and make a projected image of the sun. And if you haven't played with that yet, it's going to be dark when we're done with this. But another time when you come here, you should try to look at the sun. And you will be in good company making projected images of the sun, because look at this. Hevelius, our guy who didn't like telescopes and made his cherubs not want to use telescopes to map the night skies, had a solar telescope pretty like it. It's not have an enclosed bit, but it's still using this telescope to make a projected image of the sun in his laboratory. And so the sun would be here. He's still got his sextants and things hanging around, but he's got a few telescopes. And he's using a telescope here to look at the sun. And another particularly notable kind of record of sunspots will be Galileo. We'll come back to Galileo later and how sunspots were important in his kind of understanding of the universe that we live in. But it's pretty neat to see sunspots drawn by Galileo. I was a big fan of this one, which is actually, this is the only picture in my book that is a real book that is physically in the Haverford collection. So we also have a special collection, and I sometimes take classes to it to look at books, and I discovered this, which is the Sphere of Marcus Manilius, written by Sir Edward Sherborne, and it was written in 1675. And so it's kind of a poem about astronomy, but then what Edward Sherborne did was include lots of like context and astronomy information kind of alongside the poem. It's kind of interesting. And what struck me about this image of the sun was how much it looked like this kind of image of the sun, right? This is a modern image of the sun taken through a H-alpha filter where you see these prominences and you see the kind of boiling surface. You can see the sort of convection cells. I always like to describe this. I don't know if you've ever had really nice miso soup and you let it sit for a while and it makes those convection cells, just the same physics going on in the sun, just a little bit hotter. There's no way Edward Sherborne knew about that. There were no telescopes that did that, I don't think, in 1675. And so I think this is just like a fanciful imagining of the sun as an actual landscape that you could, fire beings could be living on, which of course is not what we think is happening. But I just enjoyed how much it looked like our modern view of the sun. So I thought that was really neat. Okay, now we're going to go to the moon. And so we're going to have a little astronomy lesson before we go to the moon, which is about how we see the moon. So the moon orbits the Earth. We all know that, I hope. But it's a really common idea to say the moon doesn't rotate. The moon also rotates. But what the moon does is it always shows its same side towards the Earth. So you can see my moon is going around once in exactly the same amount of time as it takes to revolve around the Earth. If it didn't, the Earth would see one side of it for half the time and the other side of it for the other half of the time, right? So, but because it's actually tidally locked, this cool physics thing that I really enjoy. This process has meant that we only ever see this near side of the moon. You never see the far side. However, we do see the dark side because the moon doesn't make its own light. So let's go over here. The moon is only shining because the sun's shining on it and it's reflecting light. So half of the time, the far side is lit up, and the other half of the time, the near side is lit up. So this is when we have a full moon, right? When the moon's on that side of the Earth. And you get your new moon over here, and then the beautiful phases in between. Okay, this was a long explanation for this slide, which shows one of the first recorded drawings, detailed drawings of the near side of the moon, some of which is dark, some of which is lit up. It's from Galileo in 1610. So again, some of the first telescopic observations looking at the moon. And you can see the beautiful kind of evidence of mountains, right? The shadow is not perfectly smooth. So the moon is not a perfect sphere. It has ups and downs and structure and stuff. But the very first image we have of the far side of the moon, so that side of the moon that never faces towards the Earth, but is half of the time lit up, doesn't come until 1959 when we were able to send a spacecraft behind it, which I think is kind of neat, that contrast. And then Hevelius also gets in on the act in this, so again, he's one of my favorites, I think. And look at the massive telescope, the guy who doesn't like telescopes built. So I guess he became a convert, and so he built this cool telescope, which you could never build today. So this is because it illustrates one of the points about telescopes is the tube doesn't really matter. What matters is lining up the lenses really accurately, right? So as long as you've got your lenses lined up really accurately, you can have a telescope. We put the tube there because there's lights elsewhere and stuff, and sometimes for engineering. So Hevelius came up with this way of building this huge telescope without having to build the whole tube while lining it up, and could only do it because it must have been really dark at night. There's not a lot of city lights and things like that. So he was able to still have darkness to do his telescopic observations. And what he did was observe the moon and make the first map of all of the moon that we can ever see. So I kind of cheated when I showed, oops, it's too bad. Kind of cheated when I showed you this. It's not it's not a cartoon either, right? But the moon wiggles a bit. So you see a bit more than half of it. And that's called libration. And I'm going backwards, sorry. And so you can see a bit more than just one circle of the moon. You see this extra stuff that you only see some of the time because it wiggles a bit. And we've got cherubs again, of course, because it's Hevelius. So that's fun. Okay, just a little bit more moon. Still going backwards, sorry. Some of the first photographs of the moon. Actually, the moon was one of the first objects that has photographs published in books because it's a really cool target for photography. A lot of neat parallels between history of astronomy and history of photography. And so here is an early photograph of the moon, and also these really beautiful drawings of craters on the moon. Really, really charming in this book. The moon considered a planet, a world, and a satellite. So it's a really cool book where they're trying to kind of understand the moon as a place that you might walk around on the surface. And I thought it was really interesting in this book. I've forgotten the date of the book. 1903 it's published. They didn't yet really understand what the craters were. And so there's these plates in the book where they're saying, maybe they're volcanoes. We're not really sure. These days we really understand the craters as impact craters, showing the history of bombardment of asteroids and comets on the moon. The moon, astronomically, is basically the same place as the Earth. So one of the things that sometimes is a little bit scary is this thought that actually the Earth has been hit just as much as the moon. But because the Earth has erosion and water and an atmosphere, we don't see as many craters. It's a really long time scale, though, right? So we don't need to be too worried about it. And then you also have this really cool, this is actually a photograph of a plastic cast model they made trying to like see what the crater might look like in 3D, and then you can light it up in different angles and compare it to the moon with different illuminations. And then this is a real photo of the same crater, not at the same illumination. But I thought that was a really neat technique to make these plastic casts. Okay, so we talked about the moon and the sun. The next natural thing to talk about is eclipses, right? We're all a big fan of eclipses because many of us got to see one recently, which was pretty fun. And eclipses, they're one of these places where astronomy really intersects with just regular people all the time, because when an eclipse happens, kind of everyone notices it. And so there's a lot of really neat books about eclipses. So here's just a few examples. Here's one from 1537 describing how an eclipse happens, which I liked. So you've got the moon here going around on its orbit. Here we have the sun. These beautiful illustrations of the sun in these old books. And then you can see the shadow of the moon falling on just a little spot on Terra, on Earth down here. So not everywhere on the Earth is going to see an eclipse, because this little spot is small and it will take a path across the surface of the Earth, as illustrated by Fred Espinak's Road Atlas for the Total Solar Eclipse of 2024, which is kind of fun. So I kind of cheated. I did include more recent books than 100 years ago, and showing the little map of the path of totality. And then this one's really fun. So this one's an eclipse that happened, the date. Yes, 1654. It was a partial eclipse over large parts of Europe. So this was a little pamphlet which had illustrations of how much of the sun would be covered in different cities. And they all kind of look like this, where you can't make it out too well, but it's a little face on the moon going over the sun. And then many scholars believe that this is supposed to be a cartoon version of Galileo. The telescope here looks quite a lot like Galileo's telescope, and he's going, oh my goodness. And then the words, I believe these words up here, sorry, I don't read Latin, but I have the translation, says, this masked sun is going to play a joke on me. And it was sort of a pamphlet made to tell people don't freak out about the eclipse, basically, which is pretty fun. All right, one last thing on eclipses. At Haverford, we signed up to be part of the Astronomers Without Borders eclipse glasses recycling. And we've been sent like 20,000 eclipse glasses, which is kind of funny because like there's 2 astronomers at Haverford. So we got a lot of eclipse glasses to sort at the moment, but we're working on it, and my students are helping me. And hopefully we'll pattern them up like this, and then the Astronomers Without Borders will tell us where to send them, and they'll get used in future eclipses. All right, so we're going to move on to planets a little bit. So you get a little astronomy lesson as we talk about what kind of planets might appear in early books about astronomy. So I found these videos online, which make the point for me quite nicely. One thing I should say about them though, is I think that where it says 200 days and 2 days, they mean 2 years and 200 years. I think they got their units wrong. So minus 1 point for that. Always think about your units. Okay, why do I know it's 2 years? Well, if you watch the Earth, it goes around twice. And I know that a year is how long it takes the Earth to go around the sun, right? But it makes the point quite nicely, which is that if you look, we're here on the Earth going around the sun, and if we look, Mercury and Venus are always going to be kind of near the sun, right? They're orbiting around the sun inside of the Earth's orbit. So you always see them kind of near the sun, and they kind of look like they jump between evening and morning, because you don't see them when they're right in front of the sun, and you don't see them when they're behind the sun. You only see them like when they're in the evening sky and the morning sky. They're kind of challenging to observe. Mars, on the other hand, sometimes is really far from the Earth, and then look, whoops, we're going to go close to Mars. That's called opposition. Now we're going to be really far away from Mars. It's going to be behind the sun. And then we're going to come around and be really close to it again. There it is. Roughly every 2 years, we're really close to Mars at opposition, and it's bigger on the sky, and you get this beautiful view of it in the nighttime skies. So we're going to have lots of good observations of Mars, probably. And then we're going to zoom out to the outer solar system. So now we're doing 200 years, and all of this is zipping around inside Jupiter. And all that, so, I guess it should have made it one that was slower, but the outer planets kind of stay put, roughly speaking, at least on a timescale of a year. Jupiter takes 12 years to go around once. So it goes through one constellation every year or so. So in Chinese kind of astronomy, they use it as a marker of years. Sometimes the 12 Chinese years are related to Jupiter. And the other thing to note is that Uranus and Neptune are really far away. So at least they barely move at all on human timescales, and at least pre-telescopically they're almost impossible to see. So we're not really going to see anything of Jupiter, of Neptune and Uranus in our maps. So kind of explaining why the three main ones you're going to see are Saturn, Mars, and Jupiter. Just a quick kind of browsing through some cool old books that have maps of these things in, and I'm suddenly nervous to say this name. Can you say it for me? Yeah, no, I can't say that. It's another Dutch astronomer, Huygens, I guess, and has these beautiful drawings of Saturn. So this is a real series of images of Saturn, and as the Earth orbits around and the Saturn orbits around, we see the rings at slightly different angles. And so look at how much time Huygens must have spent observing Saturn, and he's drawing the rings at these different angles. Another really famous one, there's so many books about Mars. You could do an entire talk on books about Mars, I'm sure. A really famous one is Schiaparelli, 1877. And he published these maps of Mars, which showed these straight lines that he called canali, which is Italian for channels, but many people interpret it as meaning canals. And this kind of started this idea that it's like all over sci-fi that Mars had aliens, because they thought you can see the superhighways of the aliens on Mars. I want to point out that the kind of image Schiaparelli would have had would have been sort of more like this than the kind of image you might be used to seeing of Mars today, right? He's looking through a telescope. You can only see Mars at opposition every 2 years. So people kind of came out with books every couple of years with new maps of Mars. And this was hard work, but definitely set off some fascination with Mars amongst, I think, many, many people, so that's cool. Jupiter is one of my favorite telescopic objects. Saturn's also really cool in a small telescope. And so you also get a lot of books, a lot of illustrations of Jupiter, and so I picked out this one from Proctor in 1870, where you can see the stripes on Jupiter, which you can see pretty straightforwardly in a relatively small telescope, so that's cool. There's so many cool books, though, that have images of the planets, but we're going to keep moving. Comets get to be in books a lot, and some of the comet books are pretty fun. So the comet that's about to appear in the evening sky, I think tonight might be the first night that it's come around the sun and it's going to be in the evening sky. It's really hard to predict how bright a comet's going to get. Some of them get really, really bright, like this one from 1861, that must have been pretty spectacular. You also have this drawing from 1618 of a comet over the skies of, I forget which city, I've written it down. Doesn't look like I wrote it down. And then, people throughout history have kind of connected comets with as sort of omens of bad luck. And so here's an example of this from kind of medieval Europe, where they're kind of drawing different comets and saying, a discourse on the nature and effects of comets, and the way they're kind of bring ill fortune to the world, which we don't believe anymore to be the case, but they get to be in lots of books because lots of people thought they were important for predicting omens. And here's an example of that from China, from 2nd century China, divination by astrological and meteorological phenomena. You've got all these different drawings of comets, which in Chinese are brush stars. That's the literal translation, which is quite cute, I think. The other thing you note is, I don't think the person who made these drawings saw all these comets. They're kind of rare and unpredictable. And so you get a lot of kind of, games of telephone with what the pictures of comets look like in compilations, because they're making drawings of things that have been told look like that rather than seeing them themselves. That's cool. All right, let's keep moving on. Astronomy and culture. This was a fun bit to do. As I mentioned, I really wanted to spend some time looking at astronomy and how it intersected with culture in places in the world which I didn't know so much about. But I just want to point out all the ways that astronomy is impacting your daily life, even if you don't even think about it. You know about the day, right? So that's an astronomy thing. And the year. You'll give me that one. The month is also astronomy-ish. The month originally was the period of the orbit of the moon. Now it's gotten a bit messed up from that, but roughly speaking, the period of the orbit of the moon. Did you know, though, that the 7 days of the week are all named after astronomy objects? They're the bright ones. Maybe you did. We have Sunday after the sun, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. The language has changed a little bit, so the direct connection is sometimes a little hard to see. But if we had another bright planet, would we have 8 days in the week? Maybe. That would be kind of fun. Or if we had one less, we could have 6. I don't know which I prefer, but 8 days sound good, especially as long as we have 5 working days and 3 off. That'd be good. And then religion. And so last time I gave this talk, one of the religion professors at Haverford was sitting right in the front row and made me very nervous about this. But I think it's true that almost every religion I can think of, the dates of festivals are somehow connected to astronomy. Maybe that's just because of calendars. If you think about Easter, it's tied to the first full moon after the solstice. The Lunar New Year is also tied to the new moon. Ramadan changes with the lunar calendar. That's why it moves through the Western calendar. The Jewish festivals are also typically tied to when the full moon, or relation between the full moon and the other calendar. So all of these connections between our calendar really and astronomy. Okay, so let's go to different cultures that I'm less familiar with. So I knew a little bit about Mayan codexes, or the Dresden Codex and the Maya culture, because it's kind of famous in astronomy. I once ended up debating whether the world was going to end in 2012 on a radio show. It didn't, right? So the Mayan long count ended in 2012 though, so there was a lot of the world's going to end in 2012. The Mayan long count just kind of reset to 0 and we go again, so it's okay. A lot of that though was based on these codexes, which I read about. Only 4 of these survived from Mayan culture. There must have been hundreds of them. Enormous amounts of them were burned when mostly the Spanish came and colonized this area of the world. But these 4 survived, and this one in particular, the Dresden Codex, was sent to Dresden and was held there, and so that's one of the reasons it survived and got its name. And it has tons of astronomy in it, which is why most astronomers have heard of it. So it was fun to kind of learn more about this. I cannot read Mayan, just to be clear. So I read about people's study of this. So there's some cool papers. But so for example, here we have kind of a picture of a serpent, and it turns out this is the pictogram for the sun. So this is talking about a solar eclipse. So that's kind of cool. And then they also had a lot of records of the motions of Mars and Venus, not too surprisingly. And so supposedly the numbers that you see on here, and this is the Mayan numbers, so you can see all these dots and things are numbers. And I think the sideways ones are also numbers, are counting the time it takes from Venus to go from an evening star through to a morning star back to an evening star, which turns out to be about 2 years. And the count there is about right. Also in Mesoamerica, this is a book called The General History of Things in New Spain. Sometimes it gets called the Florentine Codex. It is a record of the history of the Nahua people in the 16th century. So you think you have never heard of the Nahua people. They're more commonly known as Aztecs. But in writing this book, I learned that Nahua is a more kind of inclusive term for Aztecs, which includes some other cultures. The book is, one side is in Spanish and one side is in Nahua. I don't read either of them, so I'm having a hard time remembering which is which. This monk actually spent a lot of time living in this part of the world, working with Nahua people to record their culture. So there's a whole section on their astronomy. And I was really struck by this, learning about this, right? The Nahua people, and actually many people in Mesoamerica, when they look at the moon, they see a rabbit in the moon. So I was always taught there was a man in the moon. That's kind of the European culture. And so here is an example of that from 18th century children's picture book. But I knew because, so my husband is Chinese American, and so I know a little bit more about Chinese culture. I knew that the rabbit in the moon was an Asian thing. This is an example of it from a really cool series of books from 19th century Japan, which is 100 aspects of the moon. So it was 100 different images that feature the moon in some way. And interestingly, it's published in Japan, but it's actually a Chinese kind of mythology. This is the Monkey King, and here's the rabbit in the moon. So I thought I'd include the moon here, and we could look for the man in the moon and the rabbit in the moon. And what's interesting, now I see the rabbit way more easily. So here's the rabbit's ears, and the rabbit's face. Sorry, this laser pointer has terrible battery. And the rabbit's body. The man is, so it's one eye, the other eye, nose, and mouth. Anyway, but it's just patterns in what we see. It's like the constellations. It's kind of arbitrary what we see. But I thought it was really interesting that Mesoamerica and Asia both had rabbit. Europe had a man and moon. That was cool. So I skip over some of the Asian astronomy maybe, but there's some really cool astronomy in Asia as well. I want to make sure that we don't run out of time here. A huge amount of astronomy through history was published because of people's interest in astrology. So we were talking earlier about how we feel about astrology. And I think, it's cool that people are interested in it. And throughout history, people have been interested in it. And that has led to a lot of funding for astronomy historically, where astronomical measurements were funded because people wanted to know where the stars were because they cared about astrology. So here's a few examples of books that were published which record astronomy of the time but are really kind of astrology books. The Important Stars Amongst the Multitude of the Heavens was a book to try to teach people in Timbuktu to do astrology. And this is a chart probably to do with aligning with East. It's from a set of books called the Timbuktu manuscripts, which were saved in Timbuktu in a cave, or not in a cave, sorry, that's a different story. There's a really cool story about them though. I read the book about like saving the Timbuktu manuscripts from being destroyed by the current people in power in this part of the world. And then you also have the Wonders of Creation, which is really cool and has all these neat illustrations of constellations, again from 14th century Iran. So sort of the medieval era Islamic age was very cultured and had a lot of astronomy and stuff going on. Oh, a different laser pointer, thank you. Much appreciated. Okay. So, but we're kind of losing, so we're talking about astronomy and culture and wanting to kind of just have a little segue into how we're kind of losing that a little bit with the light pollution that we have. And I don't know, I actually got here this morning, so I haven't seen Louisville yet at nighttime. So when I go outside, I get to see, not good. The skies are not good here. They're not good in Philly either. Yeah. Yeah. So I live like here. So you can see how great it is there. We're losing this connection with the night sky. Unfortunately, we're learning to be scared of the dark. We're forgetting that if you're outside at night and the lights are dim, your eyes will adjust. They're adjusted in here. When you're outside, it's going to look really bright. So the skies are really disappearing. So here's an example of the Orion constellation from a really dark site. I think somewhere in Utah. And here's an example of what it's going to look like from a sort of typical city. Actually, I think that's pretty good. I don't see it that well from suburban Philadelphia very often. So just a little shout out to think about lighting a little bit more carefully. Do we really need all the buildings lit up at night? This is one of the main buildings on the Haverford campus, actually pretty sensitively lit. Most of the lights are going down. Haverford is also installing these kind of adjusted lamp shades where the light is coming down. They are quite bright still and quite blue, and there's been a real shift towards blue and bright LED lighting away from the kind of redder, warmer temperature lights. And as you know, the skies are blue, right? Blue light scatters around the sky much better than red. So if you put blue light out at night, it scatters around in the atmosphere more and it obscures the stars more. If you put redder lights up, it's going to be more gentle and add less to this light pollution. So just a shout out for that. And again, there's this sort of scale that people have developed called the Bortle scale. And unfortunately, where I live now is heading into this sort of city-suburban transition where it's really hard to see stars. So that's a shame. And that's a shame because we've used the stars throughout history to really understand the universe we live in. It's a shame for lots of reasons culturally. And so now let's talk about some of the cool books about developing a model of the universe. So here are some of the early ones. We'll come back to Sacrobosco, but this is a really cool medieval textbook published in Europe in around 1230, but there's hundreds of copies of this that exist. And one of the things I really enjoy about this is it shows really clearly how this proves the Earth is not flat in medieval Europe. So it's a persistent myth that medieval Europeans believed the Earth was flat. They did not. They understood that it was round. They didn't know a lot of other things, but they did know that. And you can see that happening as you can see ships kind of disappearing over the horizon. They did think that the Earth was at the center of the universe. And so this is Ptolemy's book, The Almagest, that was published. We don't actually have an original copy of this. We only have the copies that were done again from the Islamic tradition of copying manuscripts. So Almagest is actually an Islamic translation of the Great Treatise, which is in Arabic is Al-Majesti. So it turns into the Almagest. But this is like the first record of the geocentric universe. I think I get to see a copy of one of these tomorrow. We have one at Haverford too, which is fun. This was the first book that published a heliocentric model of the universe. So this was a big innovation. We're going to move from the Earth being at the center of everything to the sun. So Copernicus, and this is the cool page where everyone looks at, we've got the Sol in the center and the orbits of the planets around it, published in 1543. There's some really cool stories about this book. It was published kind of on Copernicus's deathbed. So you can read my book if you want to know more about that. I'm going to keep going. Or someone else's book. There's a lot of stories about it. But this was actually one of the first articles I wrote. Even before we kind of laid out the full structure, I was like, we're clearly going to have Copernicus. So I'm going to just write that article while I wait for like the approval of the layout and stuff. Oh yeah, so the Harmonia Macrocosmica, that beautiful set of maps, also included some really beautiful examples of this. So this is Ptolemy's map, but in the Dutch cartography, they're really beautiful with all these beautiful illustrations around the edge. So I just wanted to show that. But they also included Copernicus, so they're more familiar with the sun at the center, and then the moon going around the Earth, and other planets. We don't have Uranus and Neptune in these yet because they haven't been discovered yet, which is kind of fun to think about. So I promised Galileo, and so this is a neat book. So I included Galileo's dialogue concerning the two chief world systems. So famously, Galileo gets big trouble with the Catholic Church for providing the evidence that the heliocentric model of the universe was correct. And at the time, the Catholic Church wasn't so into that. They also really didn't like the suggestion that the celestial objects were not perfect heavenly spheres, but in fact worlds. And the two observations that Galileo made to suggest that were these mountains on the moon and spots on the sun. But he also provided evidence that the moons of Jupiter went around Jupiter, not around the Earth, which was considered, if there's something going around Jupiter, then not everything is going around the Earth. And so that was interesting. And then probably most crucially, these are a series of drawings of Venus as it goes around the sun. And you'll notice it has phases, which suggests that it's between us and the sun sometimes, and on the other side of the sun at other times. So it's going around the sun, not the Earth. So I think Galileo must have been pretty creative, because the way he presented this in this book was as a play. So he has three characters. He has a philosopher who believes the geocentric model, and a philosopher who believed the heliocentric model, and then a sort of everyday character that they're talking with and trying to convince, I'm right, no, I'm right. I think it's a really neat way of doing it. And so this is from the title page, the illustration of them having this conversation. So I think that's pretty creative. I don't think he was very smart in the naming of them, because he calls the philosopher who believed in the geocentric model, the Earth-centered model, Simplicio, which is not maybe super politically clever, right? But anyway, it's a really clever kind of popular science book. I never leave time for Kepler and Brahe, so we're going to skip over them. So I really want to make sure to have a little bit of time to tell you about Newton. I think, again, a book that I might get to tomorrow. So we're going to sort of fast forward to a more like mathematical understanding of the universe. Newton was a big part of that. He invented calculus to try to explain the motions of comets and the motions of the planets. His book, The Principia, which is published, there was like a first edition in 1687, I think, and then later published and corrected. So even Newton makes mistakes. So if you've got any physics students in the class, even Newton made mistakes. It's very, very dry. It's all geometry. Even though he invented calculus, this book didn't use it because he thought it was too modern at the time. People wouldn't understand his explanations if he did that. But it has this one really cool illustration of a comet going around the sun and precisely following this parabola, which was the prediction from this new mathematics of the universe. So that's really cool. So we kind of move on from Newton into this era of mathematical astronomy, where astronomers really had to learn how to do coordinate transformations and spherical trigonometry and all kinds of complicated math. And one of my favorite examples of that is Mary Somerville, who was a Scottish astronomer, 1830s. She was really good at calculus, basically, and really good at explaining calculus, and so she ended up writing the textbook that was used by generations of British scientists to learn calculus. And yet most people have never heard of her, which is kind of interesting. And so I think we'll move on to Astronomy for Everyone. Mary Somerville is a great segue for that. And all of these hundreds of really cool, beautiful books that have been published to try to teach astronomy to people. So I promised Sacrobosco would come back, and his beautiful, tiny little textbook about astronomy from medieval Europe. So again, it was published in the 10th century originally. There's all kinds of rumors. Apparently I'm not good at these things. There's all kinds of rumors about where Sacrobosco was from. No one is quite sure. This illustration of him is actually from much, much later. There's no illustrations of him that are contemporary. But this charming little book describes a mostly geocentric universe. Actually, for quite some time after Copernicus became the kind of understood model for the solar system. I'm going to use the universe and the solar system interchangeably at the time of Copernicus because that's all we knew about at that moment. But I have to go back to this. You guys got to see this. So this is a really beautiful infographic that was published in 1730. Again, it's Doppelmayr was another Dutch sort of cartographer. And it's got the sun in the center, and it's got all the orbits of the planets, we've got the zodiac around it. And then in the kind of corners, there's other illustrations of understanding of astronomy at the time. So you can see a prediction for an eclipse. There's a scale model of the solar system, which is actually pretty accurate. You can see Saturn and Jupiter and the sun. Got sort of a historical overview of different models for the solar system down in this corner. But my favorite is the top corner. It's got all that text and the little dots. It's kind of hard to see, so if you zoom in, each of those little dots looks like a Copernicus illustration of the solar system. Am I getting in trouble with the mic or the pointer? You keep reading me pointers. Which way around does this go? Okay. And so you got they're all little solar systems. Okay. And so I zoomed it in, but you can't read any of this, and it's in Latin anyway. So which I also don't read. But I helped with this delightful translation. They're all supposed to be other little solar systems in 1730, which is cool. And the author, so Doppelmayr, writes, and this is paraphrased, even a cannonball would take 25 years to reach the sun. So he's talking about how far away the sun is. Even a cannonball would take 25 years. So I guess in 1730, a cannonball was the fastest thing they could think of. Yeah. And this distance is nothing compared to the vast distance of the stars, which take a cannonball almost 700,000 years to traverse. So I think it's really cool that they were starting to understand just how huge the universe is. So then we've got Newton figuring this out a bit more. Now we're going to try and explain it to other people. So that's kind of cool. All right. So, but Newton takes a bit of explaining. Not everyone is going to read Newton's Principia. Even Mary Somerville's book was a textbook for, cutting edge mathematics at the time. And so a lot of people wanted to write books explaining this more simply. So we've got James Ferguson in 1764, it's about 100 years after Newton published the Principia, writing a book called Astronomy Explained upon Sir Isaac Newton's Principles. What's cool is James Ferguson built these beautiful models, so there's all these sort of etchings of beautiful ROVs in this book, and just really delightful drawings. And this book becomes particularly notable if you believe the legend that William Herschel supposedly studied from it. So William Herschel, for the astronomers, this is a kind of an illustration of William Herschel polishing a mirror, assisted by his sister Caroline Herschel, who's also an astronomer. She's not giving him a cup of tea. This is polishing stuff for the mirror. And she was very much an astronomer's assistant. And together they did all kinds of astronomy. They discovered Uranus, and they also made this map, which is the very first map we have of the galaxy that we live in. It's the first map showing that we don't just live in a solar system, we live in a collection of stars that has a structure, and we call it the galaxy. It's like almost everything about the map is wrong, but it's like the first attempt at it. So that's great, right? It's great to be completely wrong the first time you do something, because then we learn from that and we do better next time. Okay. Another thing that I found really notable reading about books like written for education was just how many of them were written by or for women. So I was a young woman, a girl, I was a teenager in the 1990s. Was definitely, when I went to amateur astronomy nights, it was all guys. I used to take my mother with me so that I didn't feel totally out of place. I didn't feel like massively encouraged to become a physicist or an astronomer, to be honest, in the 1990s. I think things are a little better now, but they're still not great. My daughter's into computer science, and she still has this same kind of experience where she's often the only woman in the room. So I was pretty surprised to discover that in 1859, 1797, people are writing astronomy textbooks aimed at women learning to become astronomers. And so there's a couple of examples of that. This is Mrs. Bryan and her children, surrounded by astronomical instruments, and the whole book is this beautiful textbook of astronomy. This telescope teaching, this is all about using the telescope to learn about astronomy. It's written by someone, the Honorable Mrs. Ward, it says there. So that was quite cool. And another example of that comes at sort of the emergence of photography in astronomy books. So far I've mostly shown you drawings, right? But this is Annie Maunder looking through a very specially designed telescope to look at the sun, right? We need specially designed telescopes to look at the sun so we don't burn our eyes out. She and her husband are pretty famous in solar physics circles. Some of you might have heard of the Maunder cycle, or the Maunder minimum. It's named after them, to do with the cycle of how many sunspots there are on the sun. And they wrote this book, The Heavens and Their Story. The foreword, Walter says, she wrote all of it, basically. So she's writing about astronomy in general with a big focus on the sun, and these beautiful photographs of the sun that they took together. So kind of close to wrapping up here, modern astronomy is quite different to this historical astronomy. We tend to use photographs of the night sky. Everything's very digital. And we also don't tend to write books publishing the latest research. Books are really used for education, textbooks, popular science books. We've kind of moved on from books being like the cutting edge, although they're still kind of interesting. New research is going in research articles. And I just illustrated this with some cool illustrations. So here we have, I think it's supposed to be Hipparchus using one of those cross stacks to study the night sky. So he was an ancient Greek astronomer. He has a telescope, I think, from telescope teaching. And another, actually, illustration of a telescope from telescope teaching. So some of these got really, really big. Here's a guy. This is probably supposed to be Lord Ross. This is a telescope in Ireland that was built, that was kind of, the telescope's called the Great Leviathan. This is actually the telescope we have at Haverford, which is tiny compared to this, but very digital. We don't look through the eyepiece. We have a CCD even for teaching, and we have a nice mount that is run with a computer, so we don't have to learn the constellations to use this telescope at least. And it's kind of simulating what a professional telescope's like for teaching undergrads. So I kind of ended the book with some books in the last 100 years, with that sort of preface that they're a bit different, and also that it's impossible to be completely comprehensive. So you've got kind of some of my favorite books that I remember reading as a child. I was really into the Apollo missions for a while, so this was a big favorite of mine. And I'm a big fan of this book, Chasing Venus. It's a really cool book about all the adventures people had to observe transits of Venus to set the scale of the solar system. So I included some books that are important to me, like scientifically. So here are some sort of core textbooks or famous or really important books in galaxy science, right? I said I'm a galaxy person. And this was a book I was given as a prize as a high school student for being the best physics exam, I think, in my school. So it's kind of fun. Oh, and also a book that apparently no one ever read, right? But I enjoyed reading as a teenager, so that was fun. I included some textbooks I used in teaching, so OpenStax Astronomy, and some more advanced textbooks in astrophysics, and then some really recent books by people who I think write cool books. So I enjoyed doing that. So, I hope you'll enjoy that. I'm happy to send a list of all of the books to anyone who wants it. There's 101 in total that we mentioned. I made a spreadsheet with them all at some point. Yeah, it was really, really fun to do this book and learn about these books. I think I still have a lot more to learn about books. There's many more than 101 in the world. But it was fun to learn about them, and I hope you enjoyed browsing with me a little bit and learning about them. Thanks.
Okay, so this is the athletic part for me, where I run to you with this microphone if you have a question. So, first one.
So, as you mentioned, Galileo was kind of known for showing that the heavenly spheres were not perfect bodies, and he used the sunspots on the sun for that.
Mm-hmm.
But you also previously showed where somebody, I think in the mid 1100s, had done star spot diagrams.
Yeah.
So was that any information there? Was that just lost or unknown? Or?
I presume it was just lost, right? I mean, it was easy for. I found that in an article. So I can send you the article which is talking about it, this earliest record of sunspots, but it must have just been like not widely understood. Also, I think maybe, that's done pre-telescopically. I don't know if you've ever tried. So with eclipse glasses, you can look at the sun, and it's had a lot of sunspots lately. So there was some day when it was like famously had a really big sunspot, and I have like 20,000 eclipse glasses in my office at the moment. So I took a pair outside, and I looked at the sun, and I can't see sunspots with the naked eye at all. So I think I could imagine people didn't really believe that they were really sunspots, and I'm pretty sure if I look at the sun, I see lots of spots all over the place. So I can imagine it was not really believed until you have Galileo reporting it from telescopic observations. But I don't really know. So.
Hi. I know currently right now the astronomy field gets a lot of criticism for focusing on space rather than the research on Earth. And I'm wondering if you saw any evidence of that as you looked in the past and in other civilizations.
Not really, if I'm honest. I think, a lot of looking at the older books, looking at other civilizations and other cultures, it really was mostly kind of records of what they believed at the time about the skies. I would say, to the point of the criticism, sometimes it's really useful to have other models. So sometimes you can learn a lot about the Earth by studying the other planets. So when I teach introductory astronomy, I think Venus and Mars are really interesting comparison points to the Earth. Mars has much less atmosphere, is much colder, and no water on the surface. Venus has this incredibly thick atmosphere. We call it the runaway greenhouse. Lead will melt on the surface. We're really lucky to be on Earth, and it has this really good temperature range for us, and it has just enough at the moment, just enough atmospheric warming to keep us at comfortable temperatures. So I think there's a lot to learn about our own planet from studying other planets. And for me, it also kind of puts things in perspective when I think about just how much of the universe is out there. I think, let's be nice to each other, because we live in this vast universe, so why would we not be nice to each other? But that's probably a really stupid answer, but that's what I think. Sure.
You showed Tycho Brahe's big castle, or not castle, big building where he did astronomy. Where were astronomers getting funding for their work? Was it just rich people who were already rich, or you said he was in favor with the Danish king at one point? Were kings funding it?
And I keep skipping Tycho Brahe. I have the slide. So this little map of, I don't even remember which one of these is working now. So here's his castle, and then it's all this beautiful garden. Oh, thank you. So yeah, he was really in favor with the Danish royal family, and it is absolutely true that in for most of history, astronomy was done by people who had the money to do astronomy. And it's really only in the last 100 years or so that it started to become a more professional thing where people can be paid, that's your job to be an astronomer. But prior to that, you kind of had to be independently wealthy or have some kind of patron to be an astronomer. So often they have a patron, and so Tycho Brahe is an example of that. But yeah, he must have been a real character. It's kind of, like, I feel like this is an entire talk, Kepler and Brahe, which is why I keep skipping it, because there's so many stories about them, and they contributed so much. Kepler is the only person in my book to have 4 books mentioned. I think there's a couple of people with 2, but Kepler had 4, because he published so much that is so important to our understanding of astronomy today. And also, like, it was so mixed in with so much that is so not important to our understanding of astronomy today. Like, he had all some kind of wild ideas. And then Brahe was just a really interesting guy. I don't know if you've ever heard, he lost part of his nose in a duel, and did all kinds of stuff. There's all kinds of questions about how he died. If I ever wanted to write a murder mystery, it would be about what happened to Tycho Brahe, because maybe someone killed him, and I would have Mary Somerville solve it. Who's my mathematical person? That's I'm never going to do it, but it would be fun. Yeah, a lot of these are online. So a lot of the pictures I'm showing you here, it's all open source, and you can get it in the so the question is, how are any of these books online? And so my answer is, yeah, most of them are online, because so many of them are public domain now. So you can browse through them, it's pretty fun.
Earlier you showed a pamphlet from, I want to say the 1650s maybe, with the cartoon of Galileo.
Yeah.
So we kind of glossed over something amazing, which was the pamphlet was saying, hey, this is what the eclipse is going to be, which means they were predicting eclipses.
Yes.
Which is awesome, first of all.
Yeah.
So I have a 2-part question. One is this the first indicator, historical record of predicting eclipse?
Interesting.
And second part is, did you, in your exploration of all these astronomy books, come across some texts where they said, hey, this is how we predicted the eclipse?
Yeah, so the cool thing about eclipses is there's a pattern. So people predicted eclipses for a really long time, even before we really understood about orbits and why there was a pattern. There's this pattern, someone help me out here, it has a name. Thank you, the Saros pattern. And so they come in this really periodic set of, there's a pattern. I'm not doing a great job explaining it. It's been a long day, sorry. But I don't think, they didn't know about gravity yet, and they didn't know about orbits yet. Am I making that up? No, I think that's true in 1654. But because there was this pattern that people had observed over generations, they could still predict eclipses really accurately. So it's kind of cool, right? Yeah.
I'm studying the audience for a hand, if there's any questions. Going once. Okay. If not, thank you all very much for coming, and we would like to thank the speaker for a wonderful talk. I think the book is still on sale outside. So, thank you all very much for coming, and I hope to see you all next year at the next Bullitt Lecture.